This will be part 3 of our section 4.1. We want to classify this triangle PRO by its sides. Is it a right triangle? Well, it kind of looks like a right triangle, but we don't want to assume that this is a right angle. It definitely looks like that's more of a right angle than either of these. And this is in the coordinate plane, so this is definitely drawn to scale. So I can definitely assume these angles are acute. I think that's safe to say. This one you don't want to assume anything because it's really close to a right angle, so it could technically still be acute, or it might even be obtuse. How would you determine if that's a right angle? Well, if it's a right angle, then these red segments here would be perpendicular. What's the slope of this line? We're counting down 2 and 1 to the right. So slope for that segment PO, it's -2/1. Down 2, 1 to the right. Now the slope of this line, notice how it's going uphill, so it's definitely positive. I need to go up 1, 2 to the right. Up 1, 2 to the right. Up 1, 2 to the right. So slope of segment OR. Up 1, 2 to the right. What do you notice about these fractions? They're opposites and they're reciprocals. So what do you know about segment PO and segment OR? They're perpendicular. If they're perpendicular, is this a right triangle? Yes, it definitely is a right triangle. Now, I know things about right triangles. I know that the longest side is across from the biggest angle, if that makes sense. So this hypotenuse, segment PR, is definitely the longest side. So that means it's definitely longer than this one. And if it's longer than this one, then these two are not the same length. So maybe those two, you could put marks on like that. Now again, this is in the coordinate plane. So this is a pretty long segment. I don't know how long it is, but I know it's not as long as that guy, because that's the hypotenuse. Wouldn't you say that this one's definitely way longer than this guy? For sure. So what's this telling you is that this is a scalene triangle. Now, that's a sufficient way to prove this, but if you really wanted to prove it using math, you would have to calculate this. How far is it from P to R? Well, use your distance formula. Remember that? Okay, so your distance formula, you subtract and square, add in the middle. You put these coordinates, these x and y's, in there. Okay, so you use distance formula once. You got to use it again to find this length. You got to use it again to find this length. But again, you could make the argument that this is way shorter than this. It's drawn to scale. It's in a coordinate plane. When the sides of a polygon are extended, you end up getting other angles that are formed. The original angles inside this triangle, we're calling those interior angles. The angles that form a linear pair with those interior angles, we're going to call those exterior angles. So these ones that have the blue stars, those would be your exterior angles. So this is an interior angle. This angle right here makes a linear pair with it. So it's an exterior angle. Go back to that same interior angle. This one also makes a linear pair with it. So that's also an exterior angle. So you actually have two exterior angles at each vertex when you extend the lines through those vertices. This theorem 4.1 is the triangle angle sum theorem. It tells you what we talked about earlier in the lesson. The sum of the measures of the interior angles of a triangle adds up to 180. So the measure of angle A plus measure of angle B plus measure of angle C equals 180. Okay, and this is a proof of that. There's also a theorem. This is theorem 4.2. It's the exterior angle theorem. It's a shortcut. It tells you the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent remote interior angles. So here's angle 1. Notice how it's an exterior angle. It's going to equal the measure of this angle and the measure of this angle added together. The exterior angle of a triangle is the same thing as the remote interior angles added together. When we say remote interiors, those are the interior angles that don't touch the exterior angle that you have. So if you know 2 of these 3 things, you can find the other one. Here's an example. This is your exterior angle. The theorem says that the exterior angle is equal to the sum of the remote interiors. So 2x minus 5 equals x plus 70. Add these together. It's got to equal that. We'll subtract x from both sides. We'll add 5 to both sides. You'll see that x is 75. Now that's not the measure of angle JKM. Angle JKM is this angle. So we need 2 times 75, which is 50. 50 minus 5 is 145. Now we know that x is 75. How do you know that you're right? 70 plus 75 is 145. So that checks out.